Using the immersive integration capabilities of the new CATIA V5 PLM Express running on the 3D Experience platform, users can check in drawings, parts, assembly structures, and other items directly from within the CATIA V5 session. The corresponding product structure can then be explored in the web browser and promoted to the next maturity stage, in this case, Design Frozen. At any time, the product structure can be synchronized with the engineering BOM in Innovia. The data can be searched and opened directly from CATIA. You have different capabilities to open the latest revisions, the latest released revisions, or the as-saved revisions of your design. Moreover, you can select the minimal amount of assembly components you need to load to do your job. This is a key capability when working with large assemblies. In this example, we have excluded the track mechanism component of the seat from the loading operation. PLM information can be directly retrieved from the CATIA tree. For example, you can access the component's revisions, maturity states, and you can even know if there is a latest available revision. At any time, the current CATIA session can be enriched with the non-loaded components. Finally, we save the design modifications and revise the components using the integrated CATIA PLM capabilities. The function Compare for Review, available in Healing Assistant, will allow you to check if a new release of a part has been modified, and then review the modifications to validate or to reject them. The color coding will enable you to review these differences from both models. You may also rework the grouping by a simple drag and drop for a further analysis. In this next step, you will qualify the different modifications identified in the previous step and prepare a report for recording dedicated viewpoints and also tag deviation or distance analysis to the geometry, including comments and text. Each modification area is tagged with a status that you can switch to OK or Rejected. Different graphic tools are available to better analyze the differences, such as transparency level and also selective display. Once all modifications are inspected, you can create an HTML report that will summarize the status of the new release modifications. It includes snapshots from the previously defined camera, the different tags and comments that you set in the previous step. Status of modification is easily spotted by a red or green color frame. You can enlarge the picture for a better view. The Sheet Metal Design Workbench allows for the efficient designing and managing of sheet metal components. It incorporates material and process information in sheet metal-specific modeling features. The loaded subassembly is the control panel of a cardboard die cutter machine. Interior design has been done, and we will detail the sheet metal front panel. Wireframe elements have been created inside one model as a conceptual layout in order to be reused directly to create the panel and the boxes. Industrial machines require a large set of panels, doors, and boxes, which only differ by their size, flange type, and then additional walls, stamping, cutouts, and holes. The use of knowledge-based templates, which contain both common parameters and the best know-how, bring significant gains in time and ensure to obtain the right quality instantly. In our case, the creation of the front panel template requires only 30% of additional time, compared with a single usage creation. On the other hand, it saves from 70% to 90% of time at each usage. Thus, return on investment is made in the first reuse. With folding and unfolding capabilities, you can work with models at any stage of the fabrication process. There are a number of different options available to create stamps within a sheet metal part: bridge, bead, flange cutout, stiffening rib, louver, surface stamp, curve stamp, circular stamp, dowel, as well as user-defined stamps to create more complex stamping. Sheet metal parts require dedicated drawings for documentation and manufacturing. The unfolded views usually display axes for the bending or the stamps, as well as the annotations mentioning the radius, the angle, and the direction. Finally, you can export the flat pattern as a DXF file to use in your manufacturing software or send to your machine controller. CATIA Functional Model Parts, FMP, is a product for designing cast, molded, and forged parts, and related tooling with unmatched productivity and flexibility. Its free history functional design approach to defining the complete functional specification for both parts and their associated tooling makes FMP a breakthrough product for reducing the design to manufacturing cycle. In this coffee machine example, we define first a protected area to reserve space for mechanical components. Then we add some stiffeners that are automatically relimited on the shell and on the protected area. We complete the design by adding some screw holders reusing a knowledge-based template. After adding a lip to the top of the part of the machine, we complete the design by creating a grill in one feature instead of defining complex pattern-based openings. This all-in-one concept saves considerable time when elaborating on a complex form. 2D layout for 3D design, LO1, is the only product on the market where a designer works in a 3D environment with embedded 2D drafting capabilities. LO1 enables the designer to work in a familiar drafting workbench with multi-view capabilities. Users can create layout views containing geometry while getting the most of their key capabilities such as dimensions, annotations, dress-up, 2D components, and constraints. Well adapted to both 2D and 3D oriented users and to 2D consumers who want to smoothly start designing in 3D at the conceptual phase, the LO1 provides an intuitive environment to capture design content. LO1 also incorporates powerful tools for a fast and associative 3D geometry creation. This is what is used here for the pin holder creation. CATIA Functional Tolerancing and Annotation is a product addressing the easy definition and management of 3D tolerance specifications and annotations of part and assemblies. It reduces the reliance on 2D drawings by capturing all drawing information, 3D tolerance specifications, and annotations inside the 3D model. The Tolerancing Advisor command allows the user to check the correctness of all the annotations according to the selected geometrical element or existing annotation and compatible to the used standards. This is what is used here for tolerancing the keyway. Using knowledge-based templates' reuse capabilities, designers boost their productivity, reusing existing functions or components that include companies' best practices. For example, here we generate a connecting rod reusing a smart template stored in a catalog. An embedded design rule automatically chooses the right rod profile depending on the rod length. As global demand and breakthrough technologies increase the complexity of product design, engineers need more advanced desktop tools to quickly validate and release designs into production. CATIA PLM Express provides a comprehensive set of tools to stimulate complex product behavior in one unified environment. It includes motion simulation, interference checking, and fitting simulations. This enables more decisions in the virtual stage development before investing in expensive prototypes, production resources, and product launch activities.